Figure 2 shows the curve C with equation y is equal to x minus x square. So that is the quadratic curve that you can see here. And the line L with equation y is equal to mx, where m is a constant and m is in between 0 and 1. So that is the equation of the line L here, y is equal to mx. The line and the curve, they both intersect, you can see, at the origin and then at the point P. Find in terms of m the coordinates of P. So P is the point of intersection. So now how do we find out point of intersection? By equating the right hand sides. We know if y is the subject for both the equations, then equating the right hand sides will give us the point of intersection. Y is equals to, so a part y is equal to x minus x square is the equation of the quadratic, and y is equal to mx is the equation of the line there. So since both of them are having y as the subject, just take the right hand sides and equate them. So x minus x square is equal to mx. So I can factorize on the left hand side. I can take x common here. We will be left with 1 minus x is equal to mx. Now this x and this x gets cancelled. We will be left with 1 minus x is equals to m. We need the coordinates of P. Coordinates of P means both x and y. So minus x goes to the right hand side, it becomes x. M from the right hand side goes to the left, it becomes minus m. Therefore, x is equals to 1 minus m will be the x coordinate for point P. Now we need to find out the y coordinate as well. So for y coordinate, just take any one of the simple equation, because it's a point of intersection for both the curve and the line. So I can take either the line's equation or the curve's equation. It's easy to take the line's equation. Line is y is equals to mx. So instead of x, you substitute here. Y is equals to m into, instead of x, it is 1 minus m. So this will be your y coordinate for the point P. So point P will be represented by 1 minus m, comma, m into 1 minus m. So we are done with the first part here. Now, the region R1 shown shaded in figure 2 is bounded by C and L. Show that the area of R1 is 1 minus m the whole cube divided by 6. So for this, what we need to do is we need to find out this particular area. R1 is what they are asking us. So it's the curve minus the line, because the curve is on top and line is below that. So curve minus the line. So for B part here, and then integral will be, this is 0 here, and we know that the P x coordinate, we got it as 1 minus m. P's x coordinate is 1 minus m. So this will be integral 0 to 1 minus m. And then since curve is on top and line is below that, curve minus line. So curve is x minus x square minus the line. Line equation is mx. Now you just have to integrate. Integration of x is x square by 2. Integration of x square is x cube by 3 minus m into integral of x is x square by 2. Now x square by 2 minus mx square by 2, I can take x square by 2 common here, and then we will be left with 1 minus m, and then we have minus x cube by 3. We need to apply the limit 0 to 1 minus m. So since we have x on both of the terms here, the lower limit we don't have to apply because it will give you 0. You just have to apply the upper limit. So wherever we have x, we need to replace it with 1 minus m. So x square will be 1 minus m the whole square into 1 minus m divided by 2 minus x cube. X is what? 1 minus m the whole cube divided by 3. So 1 minus m the whole square into 1 minus m is 1 minus m the whole cube divided by 2 minus 1 minus m the whole cube divided by 3. So two fractions in between, subtraction, negative sign. To get the denominator, we multiply both the denominators. 3 into 2 is 6. To get the numerator, we cross multiply. So this will become 3 into 1 minus m the whole cube minus 2 into 1 minus m the whole cube. So 3 minus 2 is 1. So 1 minus 1 into 1 minus m the whole cube divided by 6. That is the area for R1. And that is what we had to prove, 1 minus m cube by 6. So now we are done with part A and part B. So now we have part C. So for part C, I need some space. So I'm just erasing this A part here. So we'll get some space for C here. Okay. So for C part, the region R2 also shown in shaded in figure 2, that is this region over here, is bounded by the curve C, the x-axis, and the line L. Given that the area of R1 is equal to area of R2, therefore R1, we know already the value. So R2 will also be the same. Find the exact value of M. We need to find the exact value of M. Now what we can do is, I'm going to find out the area under the quadratic curve. So area under the quadratic curve means, what I'm going to do is, I'm going to find out the area of this region. Area of this region is what we need to find. I'm going to find out. So this will be, this is the origin, so that will be 0. And this point we need to find out. And this is the curve, the quadratic curve. We know the quadratic curve is y is equal to x minus x square. This is the x-intercept. In order to get the x-intercept, we need to substitute for y 0. So y will be 0, x minus x square. We can take x common outside. We will get 1 minus x is equal to 0. Separately equate it to 0. X is equal to 0 and 1 minus x is equal to 0. Therefore, x is equal to 0 and x is equal to 1. 0 is here origin, so this will be 1. So to get the area under the curve and above the x-axis, so that is integral of y dx, integral a to b y dx is the standard form. So integral of a and b are the upper and lower limit, that is 0 to 1. Y is the curve's equation. Equation of the curve is x minus x square dx. So let's first integrate. X will give you x square by 2 minus x square will give you x cube by 3 and 0, 1. Since both the term is having x, 0, you don't have to put the lower limit. You just have to put the upper limit here. 1 instead of x1, 1 square by 2 is 1 by 2 minus 1 cube by 3 is 1 by 3. So here we just multiply both the denominators. 2 into 3 is 6. To get the numerator, cross multiply. 1 into 3 is 3 minus 2 into 1 is 2. This will give us 1 over 6. So we got the area under the curve and quadratic curve and above the x-axis as 1 by 6. Now this 1 by 6 is what? 1 by 6 is R1 plus R2. And we know that R1 and R2 are the same thing. So 1 is equals to R1 plus R2. And we already got the R1 value. So we'll just use that to solve the part C. Okay. So now 1 by 6 is equals to R1 plus R2. R1 is 1 minus m the whole cube is there. 1 minus m the whole cube by 6 plus R2 is also what? R1 and R2 are just the same. So 1 minus m the whole cube by 6. So this will be 1 by 6 is equals to 1 minus m the whole cube plus 1 minus m the whole cube is 2 into 1 minus m the whole cube divided by 6. You can cancel both the 6 and take this multiplication of 2 to the other side. You will get 1 by 2 is equals to 1 minus m the whole cube. We need the exact value of m. So this power of 3 goes to the left hand side and it becomes 1 by 3. Just take the reciprocal. 3 means it is 3 over 1. So if you take this power to the left hand side, it becomes the reciprocal. 3 over 1, the power will become 1 over 3 is equal to 1 minus m. Now, m, you take it to the left hand side, that becomes positive m. It's equal to 1 minus 1 by 2 to the power of 1 by 3. This can be written as 1 minus 1 to the power of anything is 1 divided by 2 to the power of 1 by 3. This is again 1 minus 1 by 2 to the power of 1 by 3 means what it is? Cube root of 2. You just have to put this in calculator to get the exact value. You can either leave it here or else you can write the answer in decimals. 1 minus 1 over cube root of 2, which is 0.206 to 3 decimal places. 0.206 to 3 decimal places. So that's it. So I hope you have understood this. Thank you for watching.